I must apologize, guys. I'm going to talk a little bit quietly. I'm at a Firestone dealership now, having some work done on my tires, so you'll hear some background noise, but hopefully you can hear this okay. So back to solving problems pertaining to right triangles that have possible 30 and 60 degree angles in them. 30, 60, 90 triangles are one of two special kinds of right triangles. The other kind of right triangle is one that is called an isosceles right triangle. It's got two 45 degree angles in it and a 90 degree angle. Our focus in this lesson is on those triangles that are 30, 60, 90 triangles. Well, in a 30-60 triangle, there's a special relationship that exists between the length of the sides. In fact, the hypotenuse of a 30-60-90 triangle is twice as long. The hypotenuse will be twice as long as the length of the side that is across from or opposite the 30-degree angle. So if the side that was opposite the 30-degree angle is 1, the hypotenuse would be 2. If the side that was opposite the 30-degree angle was 2, the hypotenuse would be twice that, or 4, and so on. So we can use this information along with our Pythagorean theorem to help us find some missing sides or a missing side of a right triangle. So let's say you've got a 20-foot ladder that's leaning against a building, and it makes an angle of 60 degrees with the ground. How far up the building does the top of the ladder reach? And we'll round our answer to the nearest tenth of a foot. So here's a picture. You can see the ladder leaning against the wall. It forms a 60-degree angle with the ground, and of course the wall stands perpendicular to the ground, and in all triangles, right or otherwise, the angles must add up to 180 degrees. So if you know you've got a 90-degree angle and a 60-degree angle, then the other angle must be 30 degrees because 90 plus 60 is 30. So this figure shows what's described, and therefore you can see that the ladder is the hypotenuse of the right triangle. So the length of the side opposite the 30-degree angle must be half of that. Half of 20 is equal to 10 feet. Because again, we said that the hypotenuse will be twice as long as that leg opposite the 30-degree angle. So 20 is twice as long as 10. So now we have a right triangle. We know two of the sides of the right triangle. We can use the Pythagorean theorem to find the third side on the building. Plus the missing length squared, it must equal the hypotenuse squared. So again, we do the squaring next. 10 squared is 100. And we want to find x squared. 20 squared is 400. So next we need to subtract 100 from each side of the equal sign. And we'll have x squared is equal to 300. And here we have an equation in the form x squared equals a. So to undo the squaring, we'll have to square root both sides. And once again, there's only one reasonable square root, the positive one. And that's because you can't have a negative length. And if I round that to the nearest tenth, that ends up being 17.3 feet. So we can say that that ladder is reaching a height of